Hello everybody, this is Mrs. Snook with notes on section 4.4, trigonometric functions of any angle. And what we're going to do in this section is we're going to write the trig functions of an angle in the coordinate plane. So we're not on the unit circle anymore, and we're not just out in free space, we're on the XY plane. We're going to be able to find reference angles, and we're going to use trigonometric functions of real numbers. First up is some tips for how to do trig functions of any angle. So note in this picture here, I have an angle drawn. The initial side is on the x-axis, and the terminal side goes through a point with coordinates x, y. And what we have to do here is take into account the fact that point may not be just one unit from the origin like it would be on the unit circle. If you recall, in the unit circle, x was the cosine of the angle theta, and then y was the sine. But when we go in the coordinate plane, we have to take into account that distance there. So now the sine of theta isn't just y, it's going to be y over r. Similarly, cosine theta is x over r. Tangent of theta is still y over x. Now, r you're going to find by using Pythagorean's theorem, and it works out to r is the square root of x squared plus y squared. The other thing is r is always going to be greater than 0. It's always positive. So no matter what you do, you should always get a positive r. So with that in mind, let's do our first example. We're going to write the 6 trig ratios for theta, and theta corresponds to the point -2, 3. So that means that here's our point -2, 3. We can drop straight down from that point to get a side of the triangle. We can then go straight back to the origin to get the other side, and r is going to be the distance from the origin to -2, 3. And so what we're going to do is use that information, and we're going to calculate the length of r, and then we can go ahead and write all of our 6 trig ratios. So first thing, let's put in x and y. Now x is a -2. It went 2 back from the origin, so we're going to have a -2 here. Y is 3. R is going to be the length of the hypotenuse of this triangle. So using Pythagorean's theorem, I'm going to say r equals, I'm going to take x and I'm going to square it. I'm going to take y and square it, add that together, and do the square root. So that gives me r equals square root of 4 plus 9, r equals square root of 13. So now I have everything I need to solve all 6 of these ratios. So sine is y over r, so 3 over square root of 13. Now don't leave it that way. Go ahead and rationalize this. All right, cosine of theta, we're going to do x over r. So -2 over square root of 13, and again rationalize. Tangent of theta, we're lucky, this works out really nicely, just y over x. So 3 over -2, that's a -2, let me make that look better. All right, now I'm ready to do my the other 3 functions, the reciprocal ones. And all I got to do is flip them over. So I started off with sine theta as 3 over square root of 13. Flip that over, and I get root 13 over 3. For secant, take your cosine, flip that over, and I get root 13 over -2. Take your tangent, flip that over. I get -2 over 3. So even though I've asked you for 6 things, once you have the first 3, the other 3 are super easy. Next thing I want to point out to you is that because we're in the coordinate plane, we have certain areas where the sine and the cosine or the tangent aren't always going to be positive. Sometimes they're going to be negative. And an easy way to remember this is ACTS, A-C-T-S. And what that stands for is all, cosine, tangent, and sine. And you're going to go clockwise around the coordinate plane. So if I start in quadrant 1, that's A for all, so quadrant 1. And what that means is all the trig functions of angles in that quadrant are going to be positive, all of them. Next is quadrant 2, which is C. C stands for cosine, and the reciprocal of cosine is secant. So cosine and secant are both positive in quadrant 4. T is quadrant 3. T stands for tangent, and its reciprocal is cotangent. So in quadrant 3, the tangent and the cotangent are positive. S is quadrant 2. S also stands for sine. Sine and its reciprocal cosecant are positive in quadrant 2. So if you just remember it as ACTS, A-C-T-S, and just work your way around the quadrants, you can very easily remember who's positive and who's negative. So let's do a little bit of practice with this. In which quadrant would cosine of theta be positive? Well, I know that quadrant 1 is positive for everybody, and C stands for cosine, and that says that quadrant 4 is positive for cosine. Which ones have sine less than 0? Well, everything's positive in quadrant 1, so it's not quadrant 1. Go around. My next one is quadrant 4. Cosine and secant are the only ones positive there. So I know quadrant 4 is where sine is less than 0. Now take a look at quadrant 3, T. In there, only tangent and cotangent are positive. So sine is also going to be negative there. And then go to S for ACTS, positive is sine and cosecant, so that's not going to work. Now let's look for where tangent is greater, where cosine is greater than 0 and tangent is greater than 0. Well, I know that all of them are greater than 0 in quadrant 1. So cosine's greater than 0 in quadrant 1, so is tangent. Cosine's also greater than 0 in quadrant 4. Tangent's greater than 0 in quadrant 3. So of those, the only time where they're both positive is quadrant 1. All right, let's do cosecant greater than 0 and secant less than 0. Cosecant is greater than 0 in quadrant 1 and quadrant 2. Secant is greater than 0 in quadrant 1 and quadrant 4. So again, the only one in common between those is quadrant 1. So our answer for that is quadrant 1. All right, now that we've oriented ourselves around the coordinate plane, let's start finding some trig values. And we've done this before where I could give you one trig function and then you figure out the others. This time we're going to figure out not only what the others are, but which quadrant it's in so that we know the positive or negative signs of our trig functions. So we're starting off with sine of theta is negative 2/3. We're going to find the we're going to find the cotangent and the cosine of theta. And we're going to keep in mind that tangent is greater than 0. So let's start with our trig identity. Sine squared theta plus cosine squared theta equals 1. I'm going to plug in what I know. Now I'm going to square it. So 4/9 plus cosine squared theta. And I'm going to rewrite 1 as 9/9. So I get cosine squared theta. I'm going to subtract 4/9 from both sides. So I get 5/9. Now I have to square root both sides. Now when you do a square root, you're solving an equation and you have to put in the square root, the rule of thumb is that you take both positive and negative if you are putting it in. Since I had to write in that square root, I take both positive and negative. and I get square root of 5 over 3. Now I need to figure out, I'm going to go ahead and get the cotangent, and then I'm going to use that to figure out if I need the positive for the cosine or the negative for the cosine. So cotangent of theta, that's just going to be x over y. Or cosine of theta over sine of theta. And since I don't have x and y, that doesn't work so well for this problem, but I do have cosine and I do have sine. So I put in my cosine, and cosine is going to be one of these. It's either positive square root of 5 over 3 or negative. And then my sine, I'm already told, is negative 2/3. Simple way to simplify a complex fraction is you can cancel denominator with denominator. And since they're both 3, boom, those go away. And I have plus or minus square root of 5 over a negative 2. Now I'm told that tangent has to be positive, so cotangent has to be positive. And when I look at this, I realize the only way I'm going to have a positive fraction is if my numerator and denominator are both negative. I have a negative 2 in the denominator, so I can't use the positive square root of 5. That means I can't use positive root 5 over 3. So my cosine of theta is just going to be the negative. So I'm just going to go ahead and take out that positive. So now my cotangent is square root of 5 over 2. That's positive. That's what I want. And my cosine is going to be a negative square root of 5 over 3. All right, next one, we're going to talk about the idea of a quadrant angle. And what that means is your initial side is always on the x-axis, and your terminal side is going to be somewhere on the x or the y-axis. So they're not going to be out in the middle. They're only going to land on the x and y-axis. So for instance, if that is my angle, I have my initial on the x, my terminal on the y, that's 90 degrees. It could also be 180 degrees. If I draw it like that. It could be 270 if I draw it like this. It can also be negative. I could go around the other way and I can do negative 90, negative 180, negative 270, and so forth. The other thing I want to point out is you notice that at 0 degrees, that went through the point 1, 0. And at pi over 2, it went through the point 0, 1. We're going to use these points to be able to figure out the sine and the cosine of our quadrant angles. So let's go ahead and do some practice with that now. We're going to find the sine and cosine of 0, pi, and 3 pi over 2. So I'm going to make myself some work area. 0, pi, 3 pi over 2. Just sectioning off some space here. And I'm going to remember that the angle 0 goes through the point 1, 0. The angle pi goes through the point negative 1, 0. And the angle 3 pi over 2 goes through the point 0, negative 1. Which means we have chosen these points such that our radius is 1. So now I don't have to divide by r's. I can just go ahead and use the x's and the y's. Or I can also keep in mind that r equals 1. So let's go ahead and do this. So sine of 0 is, let's do y over r. And I have y is 0, r is 1, so I get 0. Cosine of 0 equals x over r. X is 1, y is 1, so I get 1. Not hard. Let's do pi. Now that one is going through the point negative 1, 0. So sine of pi equals 0 over 1 equals 0. Cosine of pi equals negative 1 over 1, which equals negative 1. Now, on your own, I want you to try doing 3 pi over 2. So pause this video, and then when you come back, check your answers. Okay, so for sine of 3 pi over 2, you should have gotten -1, and for cosine, you should have gotten 0. The next tool we're going to use is called reference angles, and those are going to allow us to very easily figure out the trig functions of any angle in the coordinate plane. We're going to do these with just the special angles of 45 degrees, 30 degrees, 60 degrees, and we're going to figure out the signs, the positive or negative signs of our trig functions based upon which quadrant it's in. So first of all, the definition of a reference angle. So what that is it's the smallest angle between your given angle and the x-axis. I think of it as the shortest way to the x-axis. And these are always going to be positive. All right, so if it's in quadrant 1, right here, the reference angle and the angle are actually the same because that's the shortest distance to the x-axis. You go over here in quadrant 2, here's your angle, and just to point out, the notation of our angle is theta, and the reference angle would be theta with a little tick next to it. We call that theta prime. And notice the reference angle here, if I'm going to go straight to the y-axis, it actually ends up over here. So here is theta prime. In the third quadrant, it's going to be right here. So in here is your theta prime, and then your fourth quadrant, it's right there. Just think of it as, what's my fastest way to the x-axis? That's theta prime. So let's go ahead and find some reference angles. So first off, let's do theta's 300 degrees. So I'm just going to go ahead and mark my quadrants using degrees. Now I'm going to draw in my angle. I always start, my initial side is always on the x-axis. 300 degrees is over here somewhere. So here is angle theta. That means that right in here is your reference angle. And theta prime is going to be, let's go ahead and calculate it. This is 300 degrees here, and 0 is also 360. So my theta prime is just the difference between 360 degrees and 300 degrees. So it's 60 degrees. Okay. The next one we're going to do is theta equals 2.3. Now in the book, if it does not give you values, then what you have here is radians. Okay, so starting here at 0, and then up here we have pi over 2, which is 1.57. Over here is 3.14 pi. And then 3 pi over 2, let's do that. So 3 times second pi. And that's 4.71. And then over here we have 0, or 2 pi 6.28. So now what I'm going to do is draw in the reference angle. Sorry, I'm going to draw in the angle first. 1.57. That puts it somewhere over here. Nope, sorry, 2.3 is where I'm going for. It's still over here somewhere. So right in here is theta prime. And theta prime, that's just going to be, take 3.14, take pi, and subtract 2.3 from it. And I got 0.84 radians. Last one is negative 135 degrees. So 0 minus 90 minus 180 minus 270, negative 135 puts my original angle right about there. Reference angle is right here. That's theta prime. And theta prime is going to equal, I just need to figure out the difference between a negative 135 and negative 180. So negative 135 minus a negative 180. I'm just doing this on my calculator. I got 45. Okay, so now that we know how to find our reference angles, let's use that information to find these requested trig functions. First, it wants the cosine of 4 pi over 3. Step 1 is label, so 0, pi over 2, pi, 3 pi over 2, and this is 2 pi. Step 2, draw in the angle. Okay. Now step 3, find your reference angle. Right there. Now the difference between 4 pi over 3 and pi is just pi over 3. So my theta prime is pi over 3. So now to find the cosine of 4 pi over 3, I'm going to find the cosine of pi over 3. And you can look in your book on page 287 is a chart, and it tells me that the cosine of pi over 3 equals 1/2. Now, which quadrant is this angle in? It's in quadrant 3. A, C, T, S. Tangent and cotangent are the only things positive in quadrant 3. So therefore, my cosine of 4 pi over 3 has to be negative. So it's negative 1/2 is my answer. Okay. Let's do one more, and then we'll call it good for today. Let's do the tangent of 210 degrees. Step 1, label. Step 2, draw the angle. Okay. Step 3, reference angle. So my reference angle right here is theta prime. Theta prime is the difference between 210 and 180, so theta prime is 30 degrees. So look on your chart. So this is step 4, I think. Tangent of 30 equals, go to my chart, tangent of 30 is root 3 over 3. I am in quadrant 3. In that quadrant, tangent is positive. So the tangent of 210 equals root 3 over 3. And that's it for today, everybody. Thank you for watching and have a fantastic day.